Okay, so imagine this for a moment. You're strapped into a spacecraft. Your seat is vibrating. Your heartbeat is louder than the cabin noise. Behind you, the moon. Ahead of you, Earth's atmosphere. In a few minutes, your capsule will slam into the sky faster than a rifle bullet. Outside, plasma will wrap around the vehicle like liquid fire. Communication may disappear. Every bolt, every seal, every sensor, every calculation made years earlier now has one final chance to be right. And if something fails, there is no roadside assistance in space, no emergency landing, no second attempt, only momentum, heat, and gravity. On April 10th, 2026, four astronauts splashed down safely in the Pacific Ocean. Artemis II had gone to the moon and returned. The world celebrated. But underneath every historic success is another story, the story of what had to go right. Tonight, we look at 10 quiet risks behind one loud triumph. Number 10. The heat shield that had already surprised them. A spacecraft returning from the moon doesn't simply come home. It collides with Earth at enormous speed. That speed must be bled away through atmosphere, and atmosphere turns speed into heat. That is why Orion depends on one brutal piece of engineering, its heat shield. During Artemis I, engineers discovered unexpected wear patterns after splashdown. Material had behaved differently than predicted. Not catastrophic failure, but not perfect prediction either. And in engineering, surprise is never comforting, because a heat shield is not like paint peeling from a wall. It is the barrier between life and incineration. NASA studied the issue. Teams modeled airflow, reviewed temperatures, adjusted reentry profiles, refined assumptions. But the truth remained. Artemis II's crew would trust a system that had already shown behavior its designers didn't fully expect. During reentry, no astronaut can step outside and inspect it. No one can patch it. No one can vote for a retry. You trust the physics, or you burn. This time, it held. And because it held, most people never thought about it again. Number 9. The air inside the capsule. People often imagine danger in space as meteors, explosions, or dramatic malfunctions, but the most immediate threat is often invisible: air quality, cabin pressure, carbon dioxide levels, humidity, temperature, the exact chemical balance required for the human body to keep functioning normally. Orion's life support system exists to manage all of that continuously, quietly, without applause, without headlines. During earlier testing phases and missions, certain readings and anomalies required evaluation. That is common in spacecraft development, but common does not mean trivial, because inside a sealed capsule, minor environmental drift can become major physiological stress. Too much CO2? Headaches, confusion, reduced performance, pressure instability, immediate emergency, thermal control problems, equipment and people begin suffering together. The difference between a survivable cabin and a deadly one is often a number on a screen moving slowly in the wrong direction. And while the public saw astronauts smiling on camera, machines around them were constantly working to keep every breath normal. Success in space often looks like nothing happening. That's because the dangerous things were prevented before anyone noticed. Number 8. 40 minutes behind the moon. There are few silences more intense than mission control waiting. When Orion passed behind the moon, Earth lost direct contact. No voice transmissions, no live telemetry, no instant status updates, no reassuring green indicators, just absence. For roughly 40 minutes, four astronauts were beyond immediate reach. That doesn't mean abandoned, it means independent. Every spacecraft system still had to function. Every crew procedure still mattered. Every decision still belonged to the people inside. If something failed in that window, a power issue, navigation error, medical event, fire warning, There would be no immediate help from Houston, only training, checklists, discipline under pressure, and trust in one another. Most viewers experience blackouts as inconvenience, a Wi Fi outage, a dead phone battery. But in deep space, silence carries different weight because silence can mean everything is fine, or it can mean nobody knows yet. When signal returned, relief spread instantly. But that 40-minute gap remains one of the purest reminders that distance itself is a mission hazard. Number 7. The storm you cannot see. Space is full of violence that leaves no smoke. Radiation is one of them. Charged particles from the sun, cosmic rays from beyond the solar system, energetic events crossing emptiness at extraordinary speed. They pass through metal, through electronics, through human tissue. They damage cells quietly. They alter materials invisibly. They accumulate consequences slowly. Artemis II flew during an active solar cycle. That means increased concern over solar weather. Most days, nothing dramatic happens. And that's the trap, because risk that usually does nothing can suddenly do everything. A significant solar particle event during deep space travel can raise exposure quickly. Not because someone made a mistake, because a star erupted. No astronaut can negotiate with the sun. No engineer can switch it off. At best, missions forecast, shield, monitor, and plan. But planning is not control. This time, the solar environment remained cooperative, which means the threat stayed theoretical. Theoretical threats are easy to ignore, right until the day they become real. Number 6. The engine that had to answer. At key moments in spaceflight, a mission narrows into a single question. Will the engine ignite? Not later, not almost, now. The service module engine supports critical maneuvers, trajectory corrections, lunar flyby timing, return alignment, energy management, path home. If a burn underperforms, plans change. If a burn fails entirely, the mission may enter survival mode. People imagine spacecraft drifting freely, but drift is rarely where you want to be. Spacecraft survive through deliberate motion. Engineers test propulsion systems relentlessly. They simulate failure cases, inspect valves, review thermal limits, validate sequences, and still, at ignition time, combustion remains an act of disciplined violence. Fuel, pressure, timing, precision, thousands of components cooperating for seconds that may define the entire mission. When the engine performs correctly, it feels routine. When it doesn't, routine disappears instantly. Artemis II got the answer every crew wants. Yes, but only because physics agreed. Number 5. The suit as last resort. Astronaut suits during launch and reentry are not costumes. They are contingency plans worn on the body. If cabin conditions deteriorate, the suit becomes personal life support, pressure retention, oxygen pathways, cooling loops, visor protection, communications, emergency survival time. Every zipper matters, every connector matters. Every seal matters because the suit is designed for moments nobody wants. History has shown repeatedly that highly certified systems can still reveal hidden flaws later. That is not proof of negligence. It is proof that complexity hides inside success. A pressure garment may seem simple from outside, but it is a machine shaped like a human, and machines fail at seams, interfaces, tolerances, and assumptions. During reentry, external conditions are savage: heat outside, stress loads, rapid dynamic changes. Inside the suit, conditions must remain calm. That contrast is extraordinary. One thin engineered layer preserving life, while chaos screams just beyond it. Most viewers saw orange suits. Engineers saw hundreds of failure points successfully prevented. Number 4. The launch you can't pause. Rocket launches are strange because they look elegant and are not. They are controlled emergencies. Millions of pounds of propellant ignite beneath human beings. Structures shake, pressure surges, acoustic energy hammers the vehicle, acceleration rises, and once solid boosters ignite, they commit. They do not stop because someone changed their mind. They do not throttle down because telemetry looks ugly. They burn until finished. That makes early ascent one of the harshest phases of any mission. Abort systems exist to improve odds, but no system turns launch into safety. It turns launch into managed danger. Every second upward removes one risk and introduces another. Structural loads, aerodynamic stress, guidance transitions, stage events, separation timing. The public often sees liftoff as the beginning of adventure. Professionals know it is the beginning of consequences. Artemis II cleared the tower, cleared ascent, and continued toward history. But every successful launch is also evidence of how much had to behave correctly at once. Number 3. Where escape has limits. People love the idea of rescue systems. Hit a button. Crew saved. Story over. Reality is less cinematic. Abort systems operate within physics, not wishes. At different speeds and altitudes, the same emergency can demand very different responses. There are regions of ascent where options are stronger, regions where timing becomes unforgiving, regions where survival depends on milliseconds. That has always been true in human spaceflight. Soviet systems, Apollo systems, modern systems, no vehicle escapes physics. It only works with it. An abort tower can yank a capsule away with brutal acceleration. But after separation comes parachutes, orientation, trajectory, weather, ocean recovery, and luck. People hear escape system and imagine certainty. Engineers hear it and think probabilities. Artemis II never needed to use it. That is the best outcome. Because the best rescue system is the one never tested in crisis. Number 2, the computer that runs everything. Modern spacecraft are partly piloted by hands and largely sustained by logic. Computers monitor sensors faster than humans can. They route power, manage navigation, interpret warnings, protect systems, assist crew workload. They are the nervous system of the vehicle. But computers have their own vulnerabilities: radiation, unexpected states, software conflicts, reset behavior, sensor disagreement, false alerts. Previous Orion development phases revealed issues that required continued refinement and correction. Again, that is normal. But normal doesn't mean irrelevant, because in flight, even a harmless warning can consume precious attention, and attention is a finite resource. An astronaut solving one alert may miss another. A reboot at the wrong time may create confusion even if everything returns normally seconds later. Reliable automation feels invisible. Unreliable automation feels exhausting. Artemis II's systems supported the crew home, which means thousands of silent decisions made by code occurred correctly. Most viewers never saw that victory. They simply saw splashdown. Number 1. The number behind the smiles before missions launch. Agencies model risk, not poetically, numerically, loss of communication probabilities, engine reliability rates, structural failure scenarios, human error chains, environmental hazards, reentry margins, launch windows, all compressed into estimates. Somewhere before Artemis II flew, experts calculated the odds: odds of mission loss, odds of crew loss, odds of success. These numbers are rarely the headline because celebration prefers certainty. But astronauts do something remarkable. They proceed while knowing certainty does not exist. That is courage in technical form, not ignorance, not recklessness, understanding the danger tree and going anyway. Artemis II succeeded. That matters deeply. But success does not erase risk. It reveals that risk was present and survived this time. So when you saw 4 astronauts return from the moon, you saw the visible ending. What you didn't see were the thousands of invisible victories underneath it. The bolt that held, the valve that opened, the code that executed, the seal that sealed, the engine that answered, the sun that stayed quiet, the shield that endured. That is spaceflight, a miracle built from countless things not failing. Which of these 10 points do you think was the most unsettling? Tell me in the comments. I read more than you think. And if you want more stories where science, mystery, risk, and silence meet, subscribe now because headlines celebrate outcomes. But truth usually lives in the details. And remember, the universe doesn't reveal its secrets to those who rush, it reveals them to those who know how to look. Subscribe and keep listening to the silence.